Let's learn about orders and solve this hard AIME number 14 problem from the 2019 AIME. Let's start with a definition. The order of A mod n is the smallest positive integer d that satisfies a to the power of d is congruent to 1 mod n. Let's do an example. What's the ord of 3 mod 20? Okay, so it's going to be the minimum of d, so that 2 to the power of d is congruent to 1 mod 20. Well, in this case, a is 3. And just testing values of d, we can see that d is equal to 4. So the order of 3 mod 20 is 4. Another useful fact about order is that first we have to introduce the phi function. So the phi function says that, let's just, phi of n is the number of positive integers less than or equal to n relatively prime with n. Alright, so what is phi of n? Let's just say n is like P1, A1, P2, A2, P3, A3, and so on, all the way into Pn, An. So phi of n is just going to be n times 1 minus 1 over P1 times 1 minus 1 over P2 times dot 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 times 1 minus 1 over P to n. Note that the exponents don't matter. This should be relatively clear by intuition. Okay, so how does this phi function have to relate to order? Let's see why. So it is known that by Euler's theorem, we know that for a positive integer a, we know that a to the power of phi of n is congruent to 1 mod n. This is Euler's theorem. And let's just do a special case where n is a prime. Then the phi of n would just be p minus 1. And so, because that's the number of positive integers less than p that are relatively prime. So that's p minus 1. So Fermat's little theorem states that a to the power of p minus 1 is 1 mod p. And Euler's theorem is a generalization of Fermat's. Okay. We know this, so let's see how this can be applied to order. We know that it is known that the order of A mod n is a divisor of phi of n. Let's see an example. So let's just say n is 20, and let's just say a is 3. We've already computed this. The order is going to be 4. And that should be a divisor of phi of 20, which is 20 times 1/2 times 4/5, which is 8. And yes, 4 is the divisor of 8. This holds. Okay. So this is very important. And now let's try to solve this problem. There's one quick remark that I want to make with the phi function. We stated that the phi of n, is equal to, this is phi, but there's some controversy about that. There's multiple ways to write it. But I find that this is the easiest. Phi of n is equal to n times 1 minus 1 over p1, and so on, all the way until 1 minus 1 over p to the n. You might be wondering, or this is the prime factor. You might be wondering, what if n is a prime? Then this would be turning into p. It would just be p, because the prime number has no prime factors. But that's actually wrong. The prime number has itself as a prime factor. So it would be p times 1 minus 1 over p. And that's p minus 1. That's why it's p minus 1, not p. Okay, let's go try to solve this hard AIME problem. Okay, so basically, find the least odd prime factor of 2019 to the power of 8 plus 1. So let's just say this number is going to be a multiple of p. So then 2 to the power of 19, 2019 to the power of 8 plus 1 is congruent to 0 mod p. This is simple modular arithmetic. Then we know that 2019 to the power of 8 is congruent to negative 1 mod p. Squaring both sides, 2019 to the 16 is congruent to 1 mod p. Therefore, the order of p is 16. Don't see why? Because of our earlier statement, we know that the order of 2019 mod p, we know that that order has to be divisor of 16. And it can't be 8 or less, so it has to be 16. So then 16 divides phi of p, which is the theorem we stated earlier. So in the phi of p is p minus 1, so then p is 1 mod 16. Aha! Let's just write out the first few values. 17, 33, but that's not a prime. 49, but that's not a prime. 65, not a prime. 81, not a prime. Then 97, and so on. Okay, let's just start testing values. 17. So we know that we must have, for this to work, we know that this has to be a multiple of 17. Now, there's not really an easy way to go from here. You just have to bash this out, find 2019 mod 17, and then simplify. You'll see that's not a multiple of 17. If you do the exact same thing for 97, you'll see that it is a multiple of 97. And so our answer is 97. If you like this video, please like and subscribe. Thank you.